Started. For those of you who don't know me, my name is Jen DiDonato, and even though I wear many hats here, I like to sum it all up to being the Director of Sales and Marketing at 515 Technologies. I would like to thank you all for taking the time to attend our webinar, How to Build a Complete DevSecOps Pipeline Without All That Yucky, Sticky Duct Tape. If you're wondering what the heck is she talking about with duct tape, we will get into that in a few minutes. I'd like to take a minute to introduce my awesome team joining us today. We have Anthony DiDonato, who is the founder of 515 Technologies and our sister company, Critical Design Associates. Plus, he is also one of our principal architects. Adam Rubik, who is one of our automation engineers, and Zach Thurman, who is one of our automation engineering managers. Without my team, this webinar would not be possible, so thank you guys for the effort that you put into this. If you would like to connect with them on LinkedIn, their direct link will be in the chat. All right, so what cool stuff are we going to be talking about today? Well, during this webinar, we will discuss everything you need to build a complete CI/CD pipeline. The live demos will include all the necessary DevSecOps tools that you'll need to get started. That's going to include SAST, DAST, secrets, dependency mapping, container scanning. The pipeline we demonstrate will include all stages from dev to release. The cool demos that you're going to see will show how multiple developers can achieve rapid results working on feature branches. Components in the demonstration include AWS hosting, Kubernetes, feature branching, tagging, Python, and if time allows, Java Spring Boot. Each feature branch will have multiple reviewers and approvers. This functionality is referred to GitLab Review Apps. The discussion and demo will focus on building the infrastructure, workflows, pipelines, and integrated security for an application supported by multiple developers and teams. The teams represented from a typical organization would include developers, security engineers, IT operations engineers, and DevOps automation engineers. This presentation will be demo heavy and light on the slides. So we hope you enjoy the discussion and stick around until the end for any questions that you'd like to ask. Should any questions come to mind during the presentation, feel free to put those in the chat. Now I'm going to hand it off to Anthony to where he's going to explain what I meant by duct tape.
Sorry for the uncomfortable pause there as I looked for the mute button. You know, the story of my life since COVID started. All right, so what is duct tape? Obviously, we all know it is the universal and omnipotent multi-tool, effective at pretty much any task. With regard to automation engineering, DevOps, DevSecOps, what we mean by duct tape is pretty simple to describe. If you think about traditional DevOps, 8-9 years ago when we were starting out, you had a whole bunch of tools and you tried to make them work together and hope that there was effective integration. So when we moved as a company, not just as a partner, but as a user of DevOps technology, we started out with, the standards, right? Jira, Confluence, Bitbucket, SonarQube, GitGuardian, Docker, and then Sneak for business. So we were using these for different purposes, right? One was for workflow, wiki, source code management, static application security testing, and linting. All of these had a cost: secret scanning, container registries, you name it, the dependencies. The license cost for a small team was pretty high. I'd say roughly around $53,000 a year. And what we did was started to look at GitLab. As GitLab evolves over time, we decided, hey, we're going to look at this. Cost comparison is about 50%. Same number of users, all the features with all the integration saved us, $22,000 a year. It's a small team, but still pretty significant. Cutting your cost by 50% is key. So in this webinar, we're going to talk about some different technology. What we're going to start off with is a Python-based app hosted in GitLab. We're going to build a pipeline. The initial pipeline will focus on the IT operations required to support a development pipeline. We're going to use GitLab to provision and deprovision the infrastructure. So as IT operations, we're going to be building Docker images, provisioning the environment in AWS using Terraform, and eventually producing a Kubernetes cluster that can be used for the development process. The developers are going to be also using Docker, Python, some Python libraries such as Spacey and Flask, so lightweight web app, plus some natural language processing libraries to produce an application that allows you to demonstrate, or allows us to demonstrate, named entity recognition in a web-based application. If you don't know what named entity recognition is, it's a form of machine learning called natural language processing, or natural language understanding in this case. And we're going to identify the subject and object of the text entered into the application. It's really not about the app. We've done other webinars on machine learning and natural language processing. This is more about how you provision the infrastructure, secure the infrastructure, and allow developers to move effectively throughout the environment with cost controls and a minimal amount of third-party integration. So first thing we want to talk about is the difference between IT operations and DevOps. If you're here, chances are you already know what DevOps is. But IT operations, or IT ops, is the process responsible for acquiring, designing, deploying, configuring, and maintaining the physical and virtual components that comprise your IT infrastructure. So if you're a developer and you're waiting for someone to provision you a Unix box, or Linux box, or Windows box, or a SQL database, this is kind of painful, right? You want to move fast, you want to get your job done, you want to move on to the next task. IT operations sometimes can be the bottleneck, and what we're going to demonstrate here is how they can be enabled through CI/CD pipelines to provision and deprovision that infrastructure without a lot of heavy lifting. DevOps, if you're unfamiliar, is a process for accelerating the writing and updating of code responsible for creating new applications and services. So basically, building the functionality that the business needs to operate, or in some cases, even sell. We're going to use the term DevSecOps, widely used term. If you think about DevOps, which is application development coupled with IT operations, you have to add security to that equation. And DevOps is focused on continuous integration, continuous delivery, and high quality code, as well as agility in the organization. Security is often an afterthought, and security operations will typically kind of hit you from the side and let you know, hey, you missed this, you're showing up on our vulnerability scanners, and now you got to go back and clean up your code. The effective way to do that is to shift security left into the pipeline and make it a forethought as opposed to an afterthought. So we incorporate security into the DevOps pipeline to ensure that we have high quality code as well as secure code. And we'll talk about that as well. Now, from an IT operations perspective, this is what we're going to do. We're going to use Python, create a repository, build a pipeline, and that pipeline will build, test, secure, and release the developer clusters for UAT and production. So we're going to call them staging and production. They'll both of them will be enterprise Kubernetes services on Amazon, provisioned by Terraform. So let's get into the demo very quickly. Again, AWS, EKS, and Terraform coupled with GitLab to create the container, post or push the container to the registry, and then provision that container and the Kubernetes pipeline to AWS. So without further ado, back to my slides. All right, first things first, we have a number of different projects. You can see here that they're all within one group. So if I were to click on this, I have multiple projects within the same structure. So I have my AWS demo, I have a container scanning demo, I have my AWS demo infrastructure, and then I have my demo project. This is more what the developers are going to use. This is what IT ops is going to use. And this is just a simplified way of showing you that. I'm also going to peel off into a secrets demo later on, which you'll see that's not incorporated here because I used it for a blog. So AWS infrastructure, if we take a look at that first, you have a repository, and I appreciate my teammate Zach for building all this and testing and making sure it's high quality. We add these files to a repository. So this is my source code management repository for the AWS demo infrastructure project. And in there, I have a pipeline. That pipeline is effectively a file that allows me to configure the rules associated with deploying and destroying that infrastructure. So this is a lot of text, it's kind of hard to read. I'm not going to bore you with every piece there, but visually what we're doing is creating tasks and jobs to deploy the staging cluster, deploy the production cluster, and automation for the developers later to destroy staging or destroy production if they want it. Typically, you wouldn't give them the ability to destroy production, but you may have a need to do it. So let's say you're moving from AWS to Azure or to Google Cloud. It's really arbitrary at that point, because in the end, you're still producing the same result. So in this repository, we have a few things, and I'm just going to go through here. Actually, I'm going to kick off this pipeline because it takes about 15 minutes to build. So let's do that first. And then I'm going to explain to you what's in that repository. So we'll run this pipeline. And before I run it, I just want to show you something. Here's my AWS console. I'm on the Amazon Elastic Kubernetes service. You notice there's nothing here. So nothing up my sleeve is basically the message I'm giving you. I'm going to go and run that pipeline. And in 15 minutes or less, this entire environment will be provisioned for those developers. So it's going to kick off. I'm going to deploy production. I'm going to deploy staging. And my developers, Adam and Zach, are going to be using this. So when we get to later stages of the demo, they'll actually be using this infrastructure. While it's running, I'll take a walk through the files. So here's my repository. You can see that in my repository, I have my pipeline, which I showed you a moment ago. And then I have this Terraform folder. And inside of here are all the components that I need. These TF files are basically Terraform directions. So if you look at each, I'm basically saying I want to use Terraform, this version, the provider is AWS. I want to use Helm to build the cluster. And then I can go through and create my VPCs, my enterprise Kubernetes services, and my load balancing. And we'll talk about that in a second when I get to the next slide. But these are the files that we're using to drive the automation to build that environment. Here are my variables, my outputs. These are templates that are provided. GitLab provides templates for these things as well as other providers do. But this is what you use to build and provision that infrastructure. So if you go in and look at the outputs, you can see that the AWS EKS cluster or Enterprise Kubernetes Services cluster was built. The roles were created, kube config is complete, and feature configuration is complete. So these are the outputs that we would expect. And then variables. So if you wanted to change, for example, the IP address of the cluster, or change the availability groups or the subnets, any of the relative options that are associated with your Kubernetes service can be controlled through these variables. Again, I'm not going to run through every one of them. Then we have modules. So we have identity and access management role for the service account and load balancing. So here's how I'll set up my load balancing. Here's how I'll set up my IAM. Everything that's needed to build this infrastructure is included in one place. So that pipeline is off and running. And let's go take a look at what's going on there real quick. My pipeline is running. I'm deploying both production and staging at the same time. And you can see right now it's in the stage of creating the VPCs and the configuration based on those settings. And how this occurred is by leveraging automation and containers. Prior to building this pipeline, we created a container. And that container was also created using CI/CD pipelines. So here's a separate job that I will review in a moment. We'll let this keep running, and you'll see that these pipelines are moving along. And eventually, when they're finished, over here, I will have a production and a staging cluster. So you can see now that without clicking or scrolling on anything other than demonstration, I have my enterprise Kubernetes services for production and staging off to the races. They're coming up now. You can see that the resources are slowly coming up, and it says status creating. So I didn't have to do anything. The developers didn't have to do anything. All this is occurring in the background. So if I just go back, take a look at that. We'll let this keep going as I keep yapping, for lack of a better description. So what enabled that pipeline to work effectively is having a container with all the tools that we need. So what did we need? We needed, where do we go here? What we needed was a pipeline that allowed us to create a Docker container. And that Docker container is created using GitLab runners and a build stage to create this Docker image using Docker in Docker. So we're running a Docker container provided by GitLab on their infrastructure to build this image. When that image is created, it gets pushed out to this here. So we have a Docker container or image that has Terraform, the AWS CLI or command line interface, as well as the Kubernetes controls. So we built this container just so that it would have everything that we need to provision. So anytime we need to provision a Kubernetes cluster, we already have a pre-built staging environment. Now, if we look at what that encompassed, it looks pretty simple, right? But how these stages right here are driven by settings at some level, and the settings are in this Docker file. So what we're telling it is from HashiCorp Terraform, this Docker container, run an update, add the AWS CLI, go and pull down the Kubernetes control components and install it. That's all that's happening in this Docker container. So we have everything that we need to be off to the races. So we built the container. After we built that container, we then go and scan that container. So if I go back here, I have another demonstration. I built another, this could all be incorporated as one, but we built the container image, we deployed it, and we only did that because it takes about 15 minutes. And then we scanned it. Scanning is pretty simple. With GitLab, they give you all the tools that you need. Just to create a scanning instance, I don't need any third-party tools. I don't need a Sneak API key. I don't need SonarQube. I don't need anything else. I don't even need Docker scan, quite frankly. They have this pre-built template, which I'll show you how that's incorporated. For me, all I need to do is include it. Give it a variable that tells it where the Docker container is or Docker image is, and create a stage called test. When I run that pipeline, you'll see that this pipeline runs very quickly. And what it does is scans that image, checks the dependencies within the image, and produces a report. So I'll let this one run so you can see that this is a live demo. And while it's running, I'll go back to a previously completed and you can see the output. So it went through container scanning. I built the container. And then here, you can see what's occurring. It's saying, load this Docker container. And that is the container scanning with the tag 5, which is provided by GitLab on their infrastructure. I didn't have to build anything. And then it runs through and scans. So how it's scanning is it's looking for common vulnerabilities and exposures, telling me what specifically they are, which package has the issue, what the version is, and a description of the CV. Now, this is great. This is kind of ugly and relatively useless. So if I didn't have GitLab Ultimate and I wanted to download this artifact, I could download that artifact. And effectively what I get is a bunch of JSON files that I'd have to find a way to manipulate on my own or produce some kind of report. So here's my container scanning report. If I edit this with Notepad++, you can see it's JSON, right? That's great. And if you like building your own reports, here's your raw input. Here's my dependency scanning results. And you can see it's one long JSON string, which is effectively a dictionary in Python. So that's great. That's what you get for free. However, if you're dealing with a large code base or a large infrastructure or compartmentalized team, you're going to want to be able to consolidate that reporting. So when you build an image and you deploy infrastructure, GitLab Ultimate gives you the ability to have a vulnerability dashboard built into your pipeline where you can see everything that I received from that dependency scan or that container scan, so let's look at both of those, you can see all of the vulnerabilities that were found. Now, let's say I built this infrastructure, I'm going to push it out to the developers, but I know going in that I have this vulnerability associated with it. So maybe I take that and I create an issue and I say, you know what, this is a problem. We can still continue to work on development, but I want to make sure that we get this fixed. So I'm going to assign that to Zach to go and correct. And we can put a due date on there, something like that. And let's say we need to have this fixed by next week. Great. Now Zach will receive that issue and we know that we're tracking it. So if we're looking at our report, we have our list tracked and assigned. So this one's already been assigned as an issue. So I have the ability to provision the infrastructure, scan and secure the infrastructure, and build a plan of action and milestones associated with any vulnerabilities, risks, or even code quality related issues before I even hand it off to the developers. So that's my first piece. While we're waiting, I believe this may have proceeded a little faster, and we'll see. So production and staging are still being deployed, and you can see that it's going through the process and automatically creating. So we'll come back in a few minutes and take a look at this, and we'll move on. All right. So the development infrastructure, when that script is done, that IT operations automation is complete, what are we going to get? We're going to have an AWS cloud hosted infrastructure. So Amazon Web Services with 2 virtual private clouds, one for staging, one for production. In each VPC, we're going to have enterprise Kubernetes services running on an EC2 node. If the EC2 stands for Elastic Compute. So basically our compute infrastructure is running in Amazon on T2 image. We're building a load balancer that is open for ingress on port 80. And what that's going to do is allow developers to spin up a feature branch on one of the nodes in that cluster and be able to access it over the internet to visualize and see their code changes in action. This is important for merge requests or QA review or even user acceptance testing on basic features. So having multiple features running in parallel in multiple swim lanes is very valuable and really truly supports that agile approach. All of this is supported through the various components. So when we're finished, we're going to have what's called path-based routing. So we're going to have a URL, might be HTTP, blah, 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 and it'll be branch 1, branch 2. That would be feature branch 1 or feature branch 2. And they will get associated to a pod or node in that cluster to allow that developer to spin up their infrastructure and tear it down. Naturally, after the development process is complete, the merge request is complete, we'd have to give them production, which is going to mirror that development or staging environment and give them the ability to merge their code into the main branch or master branch and push it to production as well. Naturally, that would have multiple levels of approval. So we talked about IT ops. IT ops had the task. IT operations is required to build the infrastructure for developers to work on this project. Really, it's 15 minutes of effort after you build that automation using Kubernetes, AWS, and Terraform. That's going to allow developer 1 to pull out branch 1 and run it through the same pipeline, and then developer 2 to pull out branch 2. We can go on and on with the number of branches, but you get the general idea. And incorporated into the pipeline without them needing to do anything is container scanning, dependency scanning, secret scanning, static application security testing, dynamic application security testing, and API fuzzing if we choose to. In this case, we're not going to demonstrate API fuzzing. Once they're done with their development process and they've gone through all of that testing, including unit testing, which we'll show you, they would merge that request, send it to UAT, send it to production. Once those are all approved, we'd eventually get a deployed production application that looks something like this. Okay, so what does the developer do? In this case, I'm going to pretend to be the developer. I actually am a developer, but I'm going to pretend to be the developer for this project. Oh, reactivate. My PyCharm environment is not cooperating, but I've pulled the project down. So if I wanted to do that, I would get from version control, but you can see that I've already pulled down this branch. I have all the files from that project. And in this case, we're talking about this project here, which is the AWS demo project. So you see GitLab, app, images, Kubernetes, my pipeline, my Docker file, my README, and a fake private key. So this is my production application where I'm going to build branches. So here's the main branch, but you can see every tag for every version that this application has gone through, which is effectively a number of test runs that we did. So the developer would create a branch. We're going to demonstrate that in a minute. But assume I'm the developer. I have the full pipeline here, which I may or may not need. I have the ability to go and look at the application, which is something I would have to do. I see my application is here. We know that it's a Flask-based app. I have my test components in there, and I'll talk to you about this in a minute. So the developer would operate in their IDE, commit and push this code to the environment. And here you can see a graph of all the changes that have occurred over time and by who the changes were made, including approvals, merges, branches, features, all of those things. So let me give you a quick tour of the project as well. So this is my project. This is my multiple developer project. If we look at the project information, you can see all of the activity, every push, merge, who the team is. So you can see who's involved, what they've done. I have labels if I'm choosing to use labels based on priorities or other things like AWS, bug, vulnerability. And then my members, where I can control what level of access they have and when their access disappears. Naturally, I have my repository. In there, I store my files, but you can also see every commit, which tells me who did what and when, where the pipeline is, and if it's changed or moved. Any branches that were created. So this is an active branch, but if you look at all branches, you can see that there are other branches that have been merged already. Any tags that I'm using. So every version of the code goes through a tagging process, who the contributors are, what they've done on the project, a graph to show you the same thing that we saw in the IDE, which is here. And then I have issues. So as the project moves forward, I'm tracking all the issues through GitLab. So for example, I identified a SQL injection alert from an external pen tester. They sent an email in and created an issue. And then we also have an issue where verifying the sites up, verifying authentication, and investigating a vulnerability. All these can be tracked and added to merge requests or pull requests and maintained. Also in here, we have the ability to create boards, Kanban boards for sharing with management or whatever the case may be. You can see all the closed items over here. I have service desk. What this allows people to do is I create a link, they use this email and they can send in an issue. If you notice the one here where I demonstrated the SQL injection alert, that was from me. If I had requirements associated with the project, they can all be controlled here, where I might say, here's a requirement for developer access, administrative access, and user access. Maybe this is IT operations. You can see all the merge requests. There are 20 closed, 20 merged, 20 closed, and a total of 34. Then I have my pipeline. Now I have my CI/CD pipeline, which is currently running. I have my editor where I can manipulate my pipeline. I have jobs. When I kick off those pipelines, each of those is treated as a job to deploy things. So maybe running my unit tests or my container scanning is a separate job in a separate stage in a complete pipeline. I have the ability to create schedules so that I can, schedule a change control or a request for change, and it'll occur based on whichever target I'd like. And then I have test cases. If these are things that need to occur, this might be where your non-development resources have to go through and manually test things or trigger an automated test. My security dashboard, I have my vulnerability report, which we saw a moment ago, the ability to do on-demand scans, as well as a complete software bill of materials for my application. And you can see which ones have vulnerabilities. I can export this and any other components relative to security. Under deployments, I don't have any feature flags, but if I had multiple environments, they would be listed here. You see production is currently in process. And then my releases. every time I release code, all of that code is here. So the evidence and the artifacts, as well as the source code for every version that has occurred, even who did it and when. Naturally, I also have built-in registries. So if I had, Python packages that I wanted to store here, I could. Here, we're just storing containers for the demonstration and any infrastructure that we might have. For us, our infrastructure in this case is Kubernetes. We have our AWS production agent, AWS staging agent, which are still being deployed over here in this pipeline. And it did complete, so that infrastructure should be up now. Go back. There we go. We are using Terraform to provision that. So you'll see that there's a production and staging environment where we're doing the enterprise Kubernetes services. And then there's other features like monitoring, analytics, even a wiki. So if I want to provide documentation associated with my environment, so particularly with Terraform, I'm using environment variables. So what are those environment variables? If you need to get up to speed as a new developer on the team or a new IT ops individual, I can put you into the wiki and you can go and take a look. We also have the ability to put external wiki. So if you had like a SharePoint site or whatever, as well as code snippets or examples. So here is a Terraform variables file where you can see these are the variables as an example, and maybe use this as a template to get your new team members up to speed. All right, so that's just a quick tour of the environment. We'll talk about testing next. In testing, there's a lot of terminology, right? You hear development testing, user acceptance testing, production testing, which is typically monitoring, analytics, and things like that, and reporting. But when you're talking about test-driven development, there are a lot of different ways to look at testing. There's performance testing, unit testing, integration testing, system, functional. Then you have to talk about test coverage and test fixtures. And we'll talk about each of these. I'm not going to read it verbatim, but performance testing from a development perspective is pretty simple. How much time does it take to operate, to complete a function? How much CPU, memory, network, and storage does it use? All functions you can easily build into your code to establish a baseline. And then unit testing is basically testing little pieces of the code. In this case, you'd be doing a function or a class. This function is supposed to connect to the database. Okay, great. Did it work? There you go. We'll demonstrate unit testing in a moment. Integration testing is where you take multiple classes or functions and have them work in concert. A system test is testing the entire code base working together. And then a functional test usually is a single function. So you might test, again, connecting to the network, the database, your API, whatever that case may be. And then test coverage. How much of the code written actually is tested? Is it 5%, 10%, 100%? 100% is the best way to go. But that's an iteration. You might start out with critical functions and then move on to intermediate functions and then maybe low-level functions. And then test fixtures. What is the baseline? What do you assert from the function? As an example, if I had a function that says do addition, add 1 + 1, I would assert that that is going to equal to 2. And if it does not, that means that test failed. So that's a simple example. And then naturally, after you're done building the environment and testing it, you don't want to leave it up. So we have the ability to destroy it. Okay, unit testing. I'm not going to go through every one of those components of testing, but I will walk you through unit testing. So what we have here is a Python-based application that is using Flask. Flask is just a lightweight web framework. And what I'm going to do here is show you the unit tests. So in the repository, we have all these components. There's an app and there's a test folder. Inside the test folder, we have a file called http request test.py. So we're using PyTest. There is also unit test, which is built into the Python programming language. We're going to create 4 tests, and each one of those tests is going to have a function, and that test is going to be test the index route. So we want to make sure that the basic route of that particular branch is up. So HTTP request 200 equals okay. That means it was successful. So we're going to assert that it's up. and then print that it was completed successfully, or fail it. So we're going to do that for index, extract, previewer, and preview. These are not really relevant terms to anyone other than the person who wrote the app. So if you go and look at the application, that application should have functions in it that are associated with each one of those. So you see here is that from project, import, create app. So under project, these are all the components. So here's our base, here's our index route, and then we might have previewer route, preview. These are the routes associated with the app. So the app.py doesn't necessarily contain all those, but you get the general idea. Okay, so unit tests when they're run are going to show up in the pipeline. So if we go back to our demo project and we look at a pipeline that is completed before, successfully at least, we can see that, let's say this one, which was canceled. And we go through and we look at that pipeline, you can see that PyTest was called during the test phase, and it produced the results that say, run Python using PyTest and tell me what the results are. You can see that each test completed successfully. So we got 4 items. That means our test completed and the job succeeded. All right, that's unit testing. Now we'll move into discussion of security testing. So we mentioned static application security testing, or linting, so code quality, code security, dynamic application security testing, dependencies, container scanning, secret scanning, and then vulnerability management, right? After we find all these wonderful, either false positives or true positives relative to the security of our code, how do we track, manage, and assign these things for remediation? So let's start with static application security testing. You may have heard it a bunch of times, you may hear the acronym a bunch of times, but what is it? It's effectively a scanner and an analyzer. I'm going to enable this with GitLab with probably 3 lines of code in my pipeline. But static application security testing from GitLab has quite a few different analyzers. I'm not going to run through each, but you can get a general idea based on the list that's popping up. So if you're running Python, Ruby, JavaScript, C++, Go, it will lint any of this code and give you some results. It will review it, identify it for best practices, and tell you you have bad code quality or bad code security, and here's specifically why, based on a CVE, CWE, or just best practices finding, maybe like a PEP standard or something like that. The coverage in the GitLab template, I find very, very convenient. Most applications don't rely on a single programming language, especially if it's a web-based app, right? You might be dealing with JavaScript, HTML, CSS, and whatever you're using on the back end, maybe Java or Python, whatever the case may be. So dynamic application security testing is a little different. I can enable this as well with 2 lines in my pipeline with GitLab, thanks to the templates that are provided. So again, I don't need that glue. I don't need that duct tape. It's already there. I just call this template. So I go to my GitLab pipeline. I'm spinning up a Docker container that runs the OWASP Z-attack proxy, the ZAP proxy. It's going to use Selenium and a few other operations to test my application. If I want to test, I have the ability to do a baseline scan, full scan, API scan, all the normal functionality that's associated with ZAP proxy. This is all built in. This is all free. This is very easy to configure. For example, if you look here, you can see that I have Docker run -t. I'm spinning up the OWASP ZAP2 Docker stable image. I'm going to run the ZAP baseline.py, which is a Python script. And I'm going to point it at the target, http www.example.com. In our case, we're going to point it to each branch that is created. So to get that running in GitLab, all I'm doing is creating a DAST stage in my pipeline, DAST. I add the variables, which in this case, we're going to use CI variables. But here for demonstration, I'm showing you, I have my URL with my branch name, and then I have my secure log level set to debug. And the way I get this template incorporated in my pipeline is just adding the GitLab template. Now, dependencies. this is not really a discussion of dependencies, but since we're talking about Python, I thought I'd share with you this really cool image, which is basically graph theory. This is a graph of PyPy package registry showing you how all the Python libraries are connected all the way from setup tools all the way out to the peripheral where you start to hit things like Django and Warehouse and all the other Python libraries that are built off of these components. It's a pretty cool visual. Even all the source code for it's actually out there as well. This uses Gephi to build a network graph, so graph theory, to connect these things for, centrality, communities, things like that. So all of those files, all of those packages are all intertwined in some way, shape, or form if you're using Python. The reason that's important from a security perspective is, what if this one way out here has a security bug and you're using it in your code? Well, you need to track it all the way back to find out where the CV or CWE is, and you can understand how nebulous and confusing this could be. Having a tool like the dependency mapper provided by GitLab, which is Jensen, you have the ability to identify these very effectively. Container scanning, there's always best practices associated with containers. Just think of them as little tiny computers. You want to scan them before you post them. Here I'm talking about Docker Hub, but the beauty of GitLab is you don't need Docker Hub. They give you a container registry for each project. So now you can build and maintain your own, sign them, and track issues in your workflow. So historically, you might have tracked them through Jira. But in this case, you can track your issues associated with your container infrastructure, your Kubernetes infrastructure, your AWS infrastructure, all through the GitLab pipeline based on a project. Naturally, from there, you want to remediate those issues and report periodically. To turn on container scanning, it's also very easy. You have the ability to just create a test stage, point it to your Docker image, and then include the container scanning template. So let's take a look at that real quick. Container scanning, we already looked at. You can see that it'll come through and find all these things, and it gives you that vulnerability report that identifies where all the bugs are in every package versus high, medium, low, where you can sort. This report looks rather arbitrary, but if you didn't have this report, you'd be back to the JSON, which is not fun. The last thing that we're doing, or the next thing that we're doing, is secret scanning. So what are secrets? Secrets are credentials, effectively. Maybe a private key or some JSON credentials like username, password combination, or an API key, or maybe some kind of JSON web token, JWT. Those sometimes accidentally get stored in your repository. You don't want those things in your repository because, one, security is going to find it, and two, you're exposing your application and your business to risk. So let's take a look at that real quick. What in this pipeline, you'll see for this is not it. In this pipeline here, you'll see that we have secret scanning built into it. So you see here, secret detection. If we look at the editor, it was as simple as adding this line of code. So include this template. So when I look at the process, you can see all these things are occurring: build, test, staging, production, dynamic application, security testing. Here, secret detection is occurring. If I look at that pipeline, you'll see that even though it's scanned, I may have found credentials. And I know it found credentials because I purposely planted them here so that when Zach runs this pipeline, it's going to find it. So you see, warning, one leak found. If we go back to the vulnerability report for this project, and I just go and look for secrets, you'll see that it found that fake private key. It'll even take me to the file. There's the file. That's definitely a private key. Let's close that. Let's create an issue. And since we're picking on Zach for doing all this hard work, we'll give it to Adam this time. And we'll say this is a new due date. And effectively what he'd have to do is go and remediate that issue. So now this issue is being tracked as well. So we did container scanning, we did a little secret scanning, and we're tracking those issues right in the project. So An interesting concept is, okay, what is it scanning for? If I were to look at the Git leaks rule set, which is listed here, Git leaks is an open source tool. It has built-in rules for all of these things. So applications, maybe you find, AWS, it's got some Go code to go look for typical AWS creds, tells you if it finds them and points it out as a finding. Well, that's really great. What if I'm not using any of these and I'm looking for my own type of credentials? What you have with GitLab Ultimate using this template is the ability to create new rule sets. So I have a quick demo here I want to show you. Let's duplicate this. And we'll go to menu, your projects, and we'll look up secrets. So I created this public repository just to demonstrate how simple it is. So in here, I have a repo, I have my pipeline. Pipeline's really simple. I just create a test stage, I add the GitLab template. And by doing that, it gives me quite a bit of built-in functionality. So if I look at this, this is all I had to add. But if I look at the merged template, you can see that GitLab is providing me with somewhere around 40 lines of code to go and scan for secrets. It also gives me the ability to create my own rule set. So here I have a .gitlab folder and I've created custom rules. I created two of them, one called generic password, and the other one is generic JSON web token. So what I'm looking for is a case insensitive regex for the term JWT, JWT underscore token, secret or bearer. And then for my default password, I'm just looking for words like case insensitive password or pass W. And you can tweak this any way you want. But the point I'm trying to make is, aside from the built-in rules, I have the flexibility to create custom rule sets. When I run this report and I look at it, you'll see that it found all those staged credentials. So here, CMG, generic JWT detected. It takes me right to the file and says, these are, well, that's actually my file. It's a bad example. But go back. Let's see. Generic password detected. We know that all these were found, and I can create a rule or an issue off of that. So I have the ability to enable secrets in one line and customize it in a single file. All right. So I covered static application, dynamic application, dependencies in a topic. Now let me show you all of those things and how they're running in action. I'm not going to re-show you container scanning or secrets. Vulnerability management will pop back in there. But what is happening for static application security testing? So let's go look at our pipeline again on the AWS demo project. We have our pipeline. Our pipeline has multiple stages, and I will show you the visualization of this as opposed to that. So we have our build phase, then we have static application security testing. You'll see all the options that are built in there, right? So Bandit, Brakeman, ESLint, whatever code it finds based on file extension or contents, it's going to scan for that code and present rules. So spot bugs, maybe have a little Java code in there, or I'm using Python, or I'm using Node.js. It's going to look for that. Here's another one for mobile applications. So before it deploys to staging, it's going to scan all these components. When I enable that in the pipeline, well, actually Zach enabled it in the pipeline, all he did was say, add this template. For secrets detection, add this template, dependency, and so on and so forth. And then last but not least, dynamic application security testing. So when the pipeline runs, which it has 9 minutes ago, you can see that it ran the Bandit static application security testing, container scanning. It found some JavaScript, so it ran that. PyTest was our functional test, it checked for secrets, and it used SemGrep to do a little testing as well, and then deployed the application to production, and then did some dynamic application security testing. So let's work our way back. So did Bandit find anything? We don't know. We could try to read all this, but what I'm going to do is go look in the vulnerability report and look specifically for SAST findings. So I found in there that, hey, you know what? You have a high risk issue. The identifier was a Bandit test, and it was during the SAST stage. It'll tell me that debug is equal to true in my app.py, and I need to go fix that. And for some reason, my internet's going slow. It even shows you the file and the location of the code. So this should be set to false. Otherwise, my app is going to be dumping out all kinds of things I don't want to see. So let's go back. Now in the vulnerability report, we want to look at the dynamic application security testing and say, okay, show me what you found. Well, we know that there's a cross-site scripting issue. There's the absence of cross-site tokens. Then I have, it's not set up for HTTPS. I have no content security policy, cross-domain JavaScript. So I have some cross-site scripting. I probably have some SQL injection if I look deeper. You can see that these are my lows and my highs. I can sort them by severity or priority. So critical, seem to have none. Let's go with high. Okay, we got a high. We got to go fix this. It was found by the here, and here's the common weakness. So if I were to click on that, it'll take me to a description of what a reflective cross-site scripting attack is and tell me what found it. Give me some requests, give me the actual proof. So I didn't need to pay somebody to do a pen test. I know my code's busted, and it tells me how to go and fix it. And from here, I can create an issue. So go back. When we ran the container scan, or even dependency scanning. Dependency scanning didn't find anything because everything's in the container. So let's go back and look at the container, and you can see that a library in that application, this is our Python application, has a CVE. You know, one as recent as 2022. So those templates told me everything I need to know about the security of my application and my repository. All right. All in one handy dandy report. So now let's look at the complete workflow. Now, you know, we've demonstrated, we've built the infrastructure. We've demonstrated that we've scanned and tried to secure the infrastructure. Now we cut the developers loose, right? So what are they going to do? They're going to go and create a branch, in this case, branch 1. They're going to make some changes. They're going to push those changes back to the repository to get merged. So it'll either manually or automatically kick off a pipeline, but that'll be a pipeline just for that branch. And what it's going to do is create a new Docker image. It's going to scan it for security. It's going to push it out to the Kubernetes cluster on a node. And then it's going to give the user a response back that's saying, your app can now be reviewed. And that's a feature of GitLab called Review Apps, can be reviewed at this URL. And with that, I'll hand it off to Adam so he can demonstrate everything that I just showed you. All you, Adam.
Awesome. Thanks for the great intro, Anthony, and nice job on your demos. So my name's Adam. I'm going to be going over some of the stuff that Anthony had just outlined. And so basically the first thing we want to do is we just want to look at the app that we have deployed to production currently, which I can pull up on screen here. So we've seen this page a few times in some screenshots throughout the presentation, but basically this is just a web app that we have, and it can do some NER or named entity recognition in Flask. We probably won't really do much of the NER stuff today. We're just kind of trying to look at this web page, and we're going to change the way that this web page looks. So you can see the title is called Demo App for Displaying NER in Flask, and then the background color on the screen is green. So if we go back over into GitLab, we're just in our main repository section here. And so we're going to basically implement two changes or two features today. And so what I'm going to be doing and showing on screen is updating the background color. And then Zach is going to be working in the background. He's going to actually update the title that is displayed. So to create a new feature branch, we're in repositories. We go to branches. We then click the button called new branch. And we just have to give it a name. So since we're doing the background color, we'll do update background and then color, and we'll hit create new branch, and we'll just create this from main. And there we go. We can see the branch we have selected is update background color, and we basically have copied over all of the files and folders from main. To actually edit this, we could use PyCharm or VS Code or some other IDE, but GitLab also has a web IDE, which is really good for making small and simple changes. So we're going to go ahead and use that one today. So we'll click this button here called Web IDE, and then we'll be brought into GitLab's own web IDE. For updating the background color, we have to go into the app folder, project, templates, and then basically pick the template that we want to upload. From our production app here, if I go back to it, this is just called index.html, is the HTML file that's being displayed here. So when we're back in our web IDE in GitLab, that's the file we want to update. And so all of the code on screen here is just what you saw on screen on the other basically tab. So if I scroll down and I look for the background color, it's actually here on line 65. This is the hex value for green at the moment. So what we're going to do is we're just going to replace that and we're going to update it. So this will change the background to be purple. And then one thing we always want to do when we're updating our app is we just want to update the version number. So we're currently on 1.13. And since we're making some changes, we're going to move that up to 1.14. Zach is also working in the background right now to actually change the title. So I won't be showing that here, but he's also doing that. And he would basically just be updating this line actually that my cursor's over right now. So we've made our changes to the background color and we've updated the version. So the next thing we have to do is create the commit, then just give it a message. So we'll say updated background color, changed to purple, and increased version number. We will commit this to our update background color branch because that's the way we want to do it, because we don't want to just create a new branch because we've just created one for this project and we obviously don't want to commit straight to main. So we're going to commit to our background color branch that we just created, and then we'll unselect this button for creating a new merge request. We're going to do this later. Normally a developer would probably keep this on, but we kind of want to show that process a little bit more in depth. So we'll uncheck that for now, and then we'll hit commit. So our change has been committed. If we go back to the project and we switch to our update background color branch, we'll be able to see that just now we've actually made a change. We've updated it. So what we're ready to do is we're now ready to deploy into staging. So to do that, we go to CI/CD, pipelines, run pipeline, and then basically select the branch that we want to run, which is update background color. Just give it a few seconds here, and then we should just be able to hit run pipeline, and it'll start working. So this is very similar to what we've seen before with what Anthony has shown in some of the previous demos. We have our build stage, our test stage, our staging stage, and then DAST. Build is going to actually take our code, build it out into a new Docker image, and then upload it, and then test. We're going to do all our scanning, and then in staging, we're actually going to deploy the built image that we have created earlier on. So we're going to have to give this a few seconds to actually run in the background. And it shouldn't take too long. These go pretty quickly. If we just take a second, we go back to the repository. If we actually look in our updated branch, we actually can see the code that we pushed. So if we, again, go to app, project, templates, and we just take a peek at the index.html. If we go to line 65, we can see here, this is the color that we changed, which is now purple. So we definitely know for sure that in our new branch, everything, all the code was pushed through correctly. Let's just check in on the pipeline and see how it's doing. And so within the build stage, we can see we're currently actually building out our Docker image. So this may take a few more minutes to run. What I can do while you wait for that is I can actually go, Anthony has shown this off a little bit, but if we just go back into security and vulnerability, I know one thing that Anthony had briefly touched on was with the SAST tools. We had this this issue where our debug was set to true. And so Anthony has already kind of gone over this, but basically in debug, we can set this to true when we're in a development environment, but when we're in staging or production, this is definitely something you want to be false. And we already know that this actually is out in our code because it's still true here. So the security tools are really important for having built into pipelines, and just being able to find things and find issues is great. And so this is definitely one that we'd want to change in the future. If we go back to the pipeline, you can check in and see how it's doing. It looks like we finished the build stage and we're off into testing and staging. It's really important that we use a staging environment to deploy our code, because we want an environment that's identical to production, but we don't want to just always push our code to production. Within, our production app and that environment, we want that environment to be stable, where all the versions that are pushed are stable. And so we use staging as a way to test our changes to make sure that they're working correctly. So it's always important to be able to have a staging environment and a production environment. So if anything goes wrong, we're not pushing bad code or having our web app, stop working because we haven't actually tested everything properly. So it looks like our app actually has deployed into staging. It usually takes a few extra moments to actually fully update. So we'll just give that a few moments. And if we actually go in here, there is a link that gets generated. So we can click on it here and we get brought to a new web page, and we can see in our staging environment, our background color has been changed to purple. If I switch over to our production one really quickly, we can see it was green and it still is green in production, but over in staging, we can see that the background color is purple. We can also check in on Zach's changes. We go over to deployments and environments. We can see that there is also a staging environment for title. And so if we open this one up, we can see on a different basically staging environment, we can see that we have app for displaying NER and Flask, which is different to what's on production, because on production we see demo app for displaying NER and Flask. So it looks like both of our changes have worked, and we are able to push them through, and we can see them here in staging that they are working correctly. So once a developer has verified that their staging environment and that their code out there is correct, what they can do is they can create a merge request. So we go over to merge requests, and then GitLab has a really cool feature where it will recommend you to create a merge request for any commits that have been committed in the last 10 or 15 minutes. So we can see it's asking us to create a merge request for our update background color, which we basically just pushed through 4 minutes ago. So we'll click create merge request. It'll automatically give it a title, which is basically just the commit message that we had put in before. We could give it a description, but this title actually does a pretty good job of basically saying what the merge request is. I'll assign it to myself, and then everything else I'll kind of leave as default. And then a really important option to select is we want to delete the source branch when the merge request is accepted. This just helps keep our GitLab environment pretty clean. So I'll go ahead and create the merge request. And then here we can see that it's been brought up. So the merge, I can't actually merge it with main yet because I'm the developer. So we're going to need a reviewer to actually go in and approve this. So we can see the merge was blocked. All required approvals must be given. So what Zach is going to do in the background here is he's going to actually go and approve the merge, and then we'll be able to start the pipeline. So we can actually see it's already been updated. We can see that Zach has already approved the merge request. So if I refresh the page, it looks like the pipeline is ready to merge, so I can go ahead and start that process now that I've been given approval by Zach, which we can see here. So this pipeline is kicked off. I can click on it and get some more details. It looks very similar to a bunch of the pipelines we've already seen. We have our build stage, our testing stage, and our production stage, as well as DAST after. The difference between the two pipelines we've seen in this demo is that this is the production, and previously we were deploying to staging. So we'll go through, we'll build our image, we'll do all of our security scans again, and then instead of deploying to staging, instead this time we'll deploy to production, and then we'll also actually deploy or basically create a release for the code that we've created. So we'll give this a second to run in the background. It should only take a few moments. If we go back to our merge request, we can get a little bit more details here. Here we can see our security scanning has detected some vulnerabilities, which we've put in there on purpose, basically to fill out our vulnerability report. We can see that the initial pipeline that was run in my staging environment was here. Then Zach approved it. Then I merged the request, and now we can see that pipeline is running down there. There's a few other tabs here. We can see all of the commits that are part of this merge request. So normally you may have multiple commits for larger features and larger merge requests. For now, we only have the small, just updating the background color. So only one commit. We can then also see pipelines that are run in the background. So this was the pipeline that I had used to deploy to staging. If we ever need to see any more information about that, we can click here and we can actually get more information about that as well. So here we see all the different stages. And then if we want to look at the changes that were done to the app, we can also see those here. So the big change that we made for this demo was we updated the background color. So we can see this was the old line of code that we had, and then this is the new one that we are pushing through. And then we've also increased the version number from 1.13 over to 1.14. So that's basically the merge request. I believe this pipeline is pretty much done. So if we go and we double check and we check in on it again, we can see we have deployed to production and we've also created a release. So if we go back to deployments and environments, we can see we have our production environment here, which was just updated 2 minutes ago. And we can see it was basically merged between our branches of update background color and main. And then here we see our commit message of we've changed the background color to purple and we've increased the version number. So if we open this up here, we can now see that our production app is actually displaying with the background color of purple. So we've gone through staging, verified everything was correct, gone to production, and actually we can see now that our changes have made it through and they're live on production. What we would end up doing for Zach's changes is we would create another merge request, then I or a different reviewer would give that approval and we would then run that through as well and deploy that. For now though, we'll just leave it as what we can see here, which is that our production app has the background color set to purple. The last thing we'll check in here quickly is just if we're in deployments and instead of going to environments, if you go to releases, we can see we've also shipped a new release, version 1.14, which basically just contains updating the background color to purple. We could download any of the source code, any evidence. We can see basically the merge request that was used to create this release, which again is us updating our background color from green to purple and increasing the version number. So this would be all the code associated with what has gone into the new release and then who created it. So we can see that it was me and I created it 1 minute ago. So that pretty much summarizes how developers will use GitLab to update and push different changes through staging and into production. And with that, I'll hand it back over to Anthony.
Yeah, great work, Adam. Thank you. I'll share my screen. Well, Adam and Zach, I know you were a little quiet there, Zach, but we know you did a lot to support this effort. So thank you very much as well. So you got a chance to take a look at that demo. We do move quickly. We do have a Q&A as well. So if you have questions, please hold them till the end. So we provisioned the infrastructure. We secured the infrastructure. We deployed the infrastructure to the developers. The developers wrote their code, pushed it out, tested their applications, and merged and pushed to production. Now the project's complete. We don't want the developers poking around the AWS console or the VMware console. Even though they may have the skills and the aptitude, they may not be responsible for that environment. So a lot of organizations, there's compartmentalization, right? So IT operations handles the infrastructure, development handles the code. So how do we allow them to tear down and clean up when they're done or re-provision for a new effort? So what we want to do is have no developer access required. We absolutely want to control cost and sprawl, and we want to automate that process for reusable infrastructure. So let me show you how in GitLab and AWS, we use Terraform again to break down that infrastructure with the AWS CLI as well. So go back to my project. We'll go back to the original pipeline, which is where we deployed. So we have another pipeline here that says, not only do I want you to deploy to production and staging, but I want to give them the option to destroy those things. Not necessarily production every time, but if it's not really production, we could see that the cluster was provisioned successfully. All the pieces are there. Everything's up and running. It's active. This was all done through automation. We could see our networking components, our compute components, everything that's available to the environment. Networking aspects of it, subnets, things like that that were provisioned. So you can see it's all here. Without giving the developer access to this environment, all we do is build this pipeline, which I'll show you again in the editor. has a deploy and destroy, not necessarily the, no pun intended, but all of our variables are set. And if we visualize it, all we're really doing is running Kubernetes controls and Terraform to either provision or create the cluster or to destroy the cluster. So here we're changing into the root using the Amazon, CLI Kubernetes commands to delete the ingress app, which is what allowed them to come in on port 80 and then delete all, and then using Terraform to migrate the state and kick off the job. There's some other variables that are associated with the Terraform variables. And we just repeat the same for the staging and production. But what we're doing effectively is destroying the Kubernetes cluster, destroying all the components, and setting the AWS console back to no EKS environment. Therefore, we're not maintaining the costs associated with keeping that up and running when no one's using it. So we'll run that pipeline. We'll go back to that pipeline and run the destroy commands for production and for staging. So now I'm automating that process. This takes a little bit of time, as it does to create it. It takes a little bit of time to destroy it, but this is all automated and reported. So when it's done, I can get an email that says, hey, your job completed, and this is what occurred. You'll notice again, we're using that Docker container that we created called Terraform AWS CLI Kubernetes controls, latest image. So we're spinning up our Docker container again that we use to build it to destroy it. You can see that secrets are being resolved. We're launching a Docker image or Docker container using that image on the GitLab compute to connect to AWS and destroy that information. So we'll see how that's going now. Oh, we'll go back to EKS. You'll notice that it's already starting to destroy that information, and I don't have any more clusters. So the process is working. I just don't have any output other than here. So you can see that it's gone through and deleted the ingress app, things like that. Go back to the pipeline, take a look at it. It's still running, and it's running the destroy phase. So production and staging have already basically decommissioned them on the AWS side. All right. And if they want to re-provision that, they can. So let's summarize what we talked about so we can get to Q&A if there are any questions. So we discussed, DevOps, DevSecOps, and IT operations, really just to define them and delineate how they might work from a compartmentalization perspective. We talked about integrating security with the development pipeline so that we're not doing it as an afterthought. The developers know when they're pushing code what their vulnerabilities are. The project management team knows, the line of business knows, business owner, everybody has full visibility without a lot of meetings and spreadsheets flying around, all contained within the project. We showed you how to provision the environment to support the development. We showed you a complete development workflow, incorporating issue tracking, bug tracking, and security. And then we showed you how to obviously scan and then deprovision that environment without any third-party tools. Everything that was done with one platform, including issue tracking, Kanban boards, project communications, support, pipeline development, infrastructure, security, everything incorporated. So when we talk about removing the duct tape, I didn't have to log into SonarQube or log into GitHub or log into, GitGuardian or 35 other tools that I may or may not have access to. Everything was done in one console with one platform for half the price. So when we talk about removing the duct tape, that's what we're talking about. So with that being said, I'm going to move over to Jen to wrap it up.
All right. Thanks, guys, for this awesome presentation. I'd like to take a minute just to explain 515 technologies. At 515, we offer services in 3 core practice areas: DevOps, DevSecOps, machine learning and natural language processing, as well as cloud architecture and integration. It is our goal to be your go-to partner for IT automation and integration services. Our service offerings range from staff aug, managed services, or even custom projects and solutions. As you saw today, we could totally help you build a complete CI/CD pipeline that embeds security into it. Or we can just help you continue to build and mature on automation and integration that you already have. So when you need automation engineering services, we want you to think of 515 Technologies. You can learn more about us by visiting our website at 515tech.com. On behalf of 515 Technologies, we would like to thank you for your time today. We really hope you enjoyed the content.